So in this video, we're going to talk about sets. We're going to limit it to 2 sets in this video. So it's a brief video about sets. We're going to talk more about sets in other videos. So first of all, let's define what is a set. A set is a group of well-defined elements. Examples. So we're going to see the first example. So this is an example of a set. Also, a set can have numbers. Now, a set with no elements is the empty set. For example, set of days that start with the letter Y. So there's no such day that start with the letter Y. So that's an example of an empty set. Properties of sets. So in this slide, we're going to talk about belong, does not belong, subset, not subset. So we have a set A that has 1, 2, 3, A, B, C as elements. So 1, we say 1 belong to A. 2 belong to A because 2 is found in A. Notice we have set notations, so the set containing 1 and 2 is subset to A. The empty set is subset to any set. 4, 5, and 6, the elements are not found in A, so this is not subset to A. 10 does not belong to A because 10 is not found. So be careful between set and elements. Now, representation of sets, we have 3 forms. We have the descriptive form where we can describe what do we have in the set. The set builder notation, it means when we use X and that dash means such that. So for example, the first example, the set of vowels in an alphabet, that's the descriptive form. And set builder notation is X such that X is a vowel in English letters, and the roster form is when we list the elements. So the vowels are A, E, I, O, U. Another example, the set of even integers less than 10, so that's the descriptive form. And set builder notation is X such that X is even and X less than 10. In roster form is 0, 2, 4, 6, 8. The set of coins in a dollar, that's the descriptive form. In set builder notation, that X such that X is a coin of a dollar. In roster form is penny, dime, nickel, and quarter. Venn diagram. We have John Venn created Venn diagrams to show the visual relationship among sets. The universal set is represented by a rectangle, and the subsets usually with circles or ovals. So, and we denote the subset with a symbol that's similar to C. So in this case here, A is subset to U, while B is not subset to U. So let's see the first example. We have universal set that has numbers from 0 to 9, and then we have set A is subset to set U. So what are the numbers in set U? We have 0 to 9. So 3 here belongs to set U. Set A has 1, 2, 3, 9. So for example, 4 does not belong to set A here. And A is subset to U because every element in A is in U. Now the set of elements in U but not in A, so that's a complement. So we're gonna list, so we have 0, 4, 5, 6, 7, 8. So that's the elements are found in U but not in A. So we call this set the complement of set A. So 0 does not belong to A, but it belongs to U. So also let's get familiar with belong and does not belong. So elements we say belong and does not belong, while set, subset, or not subset. The complement of set A, again, are the elements in U but not in A. So we have here set U has the following elements: 1, 2, 3, circle, square, and triangle. And A is 1, 2, 3. So what are the elements of A prime or A complement? Are going to be the circle, the square, and the triangle. So these are the elements found in A prime. We have types of sets. We have the disjoint sets. They don't have anything in common. They're separated. We have the equal sets. They are the same set. We have proper subsets when A exactly subset of B, and we have sets that have common elements. So the intersection are the elements that are common between the two sets. So the intersection of sets are the elements that occur in both, and the union are all the elements in set A or B. Keep in mind for any set A intersection the empty set is empty, A union the empty set is the set itself. Sets. And we're going to use this Venn diagram to answer questions. So what are the elements in U? The elements in U are as such. Elements in B. The elements in A but not in B. The elements in A or B, so this is A union B. The intersection is the $sign 9 and 10. And now the complement of A is all the elements in U but not in A. Intersection of two sets, another example. So we need the elements that occur in both sets. In this case here we have 8 and 10. Here these two sets don't have common elements, so the intersection is an empty set. And the intersection of a set with the empty set is empty. Union of two sets, we need to list all the elements in both sets. And if an element occurs in both sets, we don't mention it twice, we just have to mention it once. Keep in mind the union of a set with the empty set is the set itself. Cardinal of a set is the number of elements in the set. And we denote the cardinal by n of A. So set A has 3 elements, so the cardinal of A is 3. Set B has numbers from 0 to 12, therefore the cardinal of B is 13. The cardinal of empty set is 0. And the set of integers, the cardinal of set of integers is infinity. So we have a trick to find the cardinality of finite sets, which is the max minus the min plus 1. The cardinality of union of two finite sets is given by the formula. So let's see an example. Some of the results of the campus survey indicated that 490 students are taken in math class, 340 students are taken in English class, and 120 students are registered in both. How many students are taken in math or an English class? So we're going to use that formula. Keep in mind E is for English, M is for math, and don't forget that we have 120 occur in both. Therefore, the number of students taking math or English is 710.